So I will present not the work we did for the university, but we took apart a femtocell to show that we can have access to the operator network and do some malicious stuff. But here I will explain how femtocell work, how they're integrated. First of all, that's the normal UML architecture. Lots of interfaces. Actually, it's very similar to GSM. The name are different. We'll come back to this one middle of the times because with femtocells it changes a bit. But first, femtocells, the operator is trying to push the femtocells because there are more and more users using 3G. Everyone wants to be connected all the time, wants to have high-speed internet and so on. And you only have just small spectrum which you can use. So the antennas get quite some load, and now the traffic, there's some traffic congestion, particularly in the cities. So what they're doing is they just give the femtocells to offload the traffic from the public line, from the public keys, base stations, to the femtocells. So now when the user is at home, it will connect automatically to the femtocell, and then the femtocell is connected to the mobile operator network over the internet. It's also sold, so the arguments to sell it, it provides 3G coverage. 3G femtocell, so if you have it at home, particularly indoors where the 2.1 GHz band doesn't go far, you will have a better signal. And the only thing you need to do is plug it to the internet. So that's also quite malicious because normally they have to pay a lot of money to install new Bs, the base stations. They have to pay a lot of money for the licenses and for the rights to install it on the roof. And then there's the maintenance cost and the hardware cost and so on. Femtocells are really cheap hardware. You don't have to pay the rights to install it somewhere because the user takes it in his home and will install it. Also, the user provides the link to the internet. It's not the operator who has to install some link to have connectivity. The user will provide the power, and the user will provide the maintenance. The operator will never send someone to configure the femtocell or to repair the femtocell. If it's broken, that's the responsibility of the user. That's why they're trying to push it. It offloads the traffic, it's very cheap. And the user provides everything. What's also not so, what's curious is even if you have the femtocell, so you pay the femtocell, you provide the power, you provide the traffic, you still need to pay for the communication you do over the femtocell. So you still have it on your bill at the end of the month. You could get rid of it, but the infrastructure is quite different, and they will have to change the billing stuff, so they don't do it. You still have to pay for it. It's a different architecture, so the architecture is in specification, and there's more security because now the device is in the user's home where the user can play with it, how with it. So they put some more recommendation, that the security, and so on. We'll see later on. So femtocells are just small cells, very small cells. If they're producing attocells, a step more, where you have 2 meter coverage, you plug it over USB, and then you can use your iPhone or whatever you want, just next to your laptop. So previously in the access network, we've seen that we have the radio network subsystem with the node B and the radio network controller, which is the gateway to the core network. With femtocells, they added a new subsystem into the access network called the home node B subsystem. So here we have the node B, the alternative is the home node B, then we have the radio network controller, the alternative is the home node B gateway, which also provide access to the core network. They added 2 elements, that's the security gateway, because you're using Ethernet and because they don't want anybody to access to the network, they're using the security gateway to cipher, to encrypt the communication, and also to authenticate the home node B. So only home node B are allowed to access to this part of the network. Behind the security gateway there is the HMS, this home management system, subsystem, system I think. Because the operator can't control the node B on place and will not configure it, it has some complete remote control. So the HMS, which is also the operation, administration, maintenance, and provisioning server, controls everything the home node B. It will set it will tell what the PT gateway is, where the home node B gateway is, what's the configuration, and so on. Complete remote control. And here we have the home node B gateway. It's quite the equivalent. We'll see later on that it's not really very equivalent. And the connection to the backend is actually exactly the same. IUPS, IUCS. There are lots of femtocells, so, and since 2 or 3 years, there are even more all the time. And there's the femto forum. Here, exactly. So in the femto forum, you'll have a list of all the femtocell provider, the name, where they're located, if you have to pay, because sometimes you just need a mobile phone subscription, then you can ask the operator, I want the femtocell because I have bad coverage. Sometimes you pay from the femtocell a monthly fee, sometimes you just pay one time, so you will see that. In SFR, the femtocell, so SFR is the second French operator, the femtocell, well, is for free. Sometimes it was 100 euros, sometimes 200 euros, but now it's for free. So they're really trying to push the femtocells, and generally you don't pay a lot for that. The only thing you need to get a femtocell is the mobile phone subscription. You only get the femtocell from the operator if you have the mobile phone subscription from this operator. Hardware really cheap. This one has so this is the French femtocell I'm going to talk about. I have other ones actually. Here we have one from Arella, that's the Turkish operator. I don't have the one from Vodafone UK anymore, I just gave it to someone. This is from Greece, so Vodafone Greece. Vodafone is the biggest one in the femtocell market because in every country where they are, they're pushing femtocells, and not the same one, so every country has its own femtocells. The Vodafone UK, it's Alcatel-Lucent femtocell, you know, because THC hacked it. This is from Greece. From Spain, there's someone else.
In Germany.
In Germany, there is one. Deutsche Telekom provides femtocells, but they only provide it for special customers.
Yeah, but not Vodafone.
No, not Vodafone. Maybe it will come, but when you see the femto forum, there is Vodafone who's selling a lot of femtocells. And this is the second version of the SFR femtocell. Yeah, second version of it. So we can pass it around. Like always, small processor, and this one has a FPGA for all the UMTS stuff. But now the processors, the ARM processor generally, have their own UMTS core for doing all the, not the signal processing itself. Then you see, like in this one, there is only a processor where all the cores are in the processor, and then you have just TX, RX. Very cheap. The vendor of this femtocell is Ubiquisys. Ubiquisys is a vendor from the UK. So what's important to say is if you have a problem with the hardware, you have to blame Ubiquisys. If you have a problem with the network, you have to blame the operator. Because the operator only buys the femtocells, configure them, and send it to the customer. They have no idea which software is running on it. It says, this is the interface, and that's it. So really, they didn't develop the software on it. What you generally find is Linux OS, like always, and then proprietary services, because simply there are 3D services that are not implemented. If there would be some security services implemented, they would probably install it. But here, they just install it, they develop their own tools to control the FPGA, to control the SIM card, and to speak with the home node B gateway. Home node B femtocell is actually different than the home node B. So first off, normally in the architecture you have the RNC controlling the node B. In this case, we don't have exactly the RNC, like the home node B gateway Where's the picture? Here. Normally your RNC controls the node B. It sets go on this channel and so on and so on. In this case, there is the RNC in here, so all the channel management is done in this box. The one who configures the channel will say you will this one is the home management server. It's not the gateway. The gateway is only here to have the data connected to the phone network. Everything that's the radio control is done by your HMS, and it's just done by the HMS in the beginning, saying you're using this configuration, you're using this channel, and so on. The femtocell will never ask again for new configuration, only when it starts. Yes, the cell configuration. The communication between the HMS and the HND is TR69, also known as auto configuration server. You see it in some ADSL modem where the operator like to push configurations. It's exactly the same here, TR69 using SOAP or XML or HTTP. And when the femtocells connect to the network, the HMS will ask for the data. Is it the last data? If it's not, it is the last data. But the HMS can at any time push any configuration to any femtocell. So the femtocell will have a listening port for this one, which supports this protocol. The data is provided at runtime, that's the provisioning, what they call, where they push which frequency you want to use, which user are allowed to connect to this femtocell, because the femtocell verifies itself if the user, if this MZ is allowed to connect to it. You have a closed subscriber group, the femtocell owner says, okay, only these 4 people are allowed to connect to this femtocell. The femtocell will verify the email, if it's allowed, you go through. The home node D gateway will not verify it. It's only the femtocell, or at least it's not implemented. Rare updates and registration. And the HMS will always also say you're for this operator using this channel, that's a closed subscriber group. Here's the security gateway address, here's the home node D address, but it's really complete remote control. Like I said, normally you have only, that's the closed, so you have 3 access modes in femtocells. The closed access mode is when you have a list of registered users which are allowed to connect to it. Then there is the semi-open mode, where all the users from this operator are allowed to connect to it. And then the complete open access mode, where everybody can connect to it. And again, it's only verified on femtocell, not in the backend. This is why 3G, building 3G in the catcher is possible, because you just have to put open access mode, you just change the MCC, the MNC, and that's done. And then your fake PTS, your fake node B. Also, you're connected to the SFR gateway, and the SFR gateway doesn't block any other operators. So it's not only they don't block the users which are not in the subscriber list, any operator, any phone from any operator can connect to the box simply because SFR allows roaming subscription. I think they didn't filter and they connected to the same backend than the normal node is. I don't know exactly.
And how do you access the hidden web network?
I'll do that, I'll show it now. So, what's nice is there is an operator web page where you only actually see the status. So the username is owner, the password is the last 4 digits of the email which is written down there. But it's not useful. You only see if it's connected or not. What they left is a secret hidden vendor web interface, which is really nice because first off, it has a login page, but if you access to the web page directly, you get the cookies, a valid cookie, you reuse the cookie, like here we reuse the cookie, I'm connected. And this vendor page is for engineering. You can do really a lot of stuff I don't understand. So here we have the network. Here it tells here's the IPsec gateway. Here you have the auto configuration server. That's the HMS. Here you have the RAN gateway. That's really the home node B gateway. So this is what the HMS pushes to the femtocell. That's a complete configuration. So this web interface is really for the configuration of it. There's also IPsec timing. Because the femtocell has a really bad clock, so every 3 seconds there will be an NTP packet to resync the clock. That's how we do it. Yeah, every 3 seconds there's an NTP synchronization. This is the web thing for the NTP synchronization. PS offload and so on. Then in the engineering I don't get everything, but the most important is here cell configuration, where you have the MNC, and the MNC you can change it, RF enable and so on. You can change also the frequencies.
And even if you don't change MSC and MCC, if you set it to open access mode, you can still then see it's SFR, but you can log in if your phone has if your operator is roaming with.
You just don't catch the other ones.
And is it possible to take a femtocell and turn it on into another country? Is it checked the neighbors?
The operator has only some special femtocell frequencies for their own country. So they must be sure before that it's in their country. There are several ways to do it. One way is just the IP, where you connect to it. The other way is GPS, but I've only seen US femtocells having GPSs. The European one doesn't. It costs a lot, like eSport costs around 100 euros. You want to put a GPS again on it, it's 20 euros. Then you need to provide an antenna because you use it indoors. Yes, you have to say, okay, put the antenna outdoors so I can get some signal. The last way they do is they scan the neighbors. These are old ones where this is not here. I didn't scan the neighbors yet. So before it's just after they connected to the CTP gateway, it will scan all the neighbors, find out which is the country code of the neighbor cells, and also the channels where they're on the cell ID. It's doing it for the UMTS, it's doing it for other neighbor femtocells, so there could be other neighbor femtocells, and for GSM. Once it has the list, it submits the list to the HMS, and the HMS will say, okay, you're in the right country, you can operate here. You can start here. And when you buy a femtocell, you don't own a license. When you connect to their network, and they provide you the license, so they still hold the license. You're not allowed to operate the femtocell outside of the network, normally. This is how they do it. Next step. So this is how they should do it. Actually, SFR doesn't care if you have a German IP, and they don't care if you have another, if you are in another country. So I don't know if we can see it. Here, evaluate country. So it found out I was in another country. It alerted the HMS, but it didn't care. It just worked. Simply because you gain money if to bring the femtocell all the way, it's still using their network. You gain more money. Now what's curious is it's as easy as in 3G. Normally you shouldn't be allowed to do easy catching because you have the mutual authentication. But the mutual authentication is just between the phone and the operator network, the home network, not the femtocell network. So because SFR allows roaming, it will just forward the authentication tokens. So as long as I have a subscription with a valid operator, I can build, I can use it as 3G easy catcher. It's by design. Simply because authentication is with the home operator. Details. I'm going to talk about the network, which is behind what's. I'm going to talk about what's in here. So present the femtocell, I'm going to talk what's about in here. We have the HMS with not only configuration, and then we have here the connection between the home node B and the home node B gateway is called AUH. In our case, it's GAN, but AUH is just the name of the interface. It's not the name of a protocol. We have different protocols. We have AUP. AUP is AUB, which the normal node B talks with the LNC over IP. Then we have AMS, which is SIP, and then we have GAN, which is Generic Access Network. In our case, we have Generic Access Network. You maybe know it as UMA. UMA, Unlicensed Mobile Access, was created by the operator in 2004, and in 2005 with 3GPP, not the 4GPP, took it and standardized it, which are these two standards. The idea of UMA was to have a dual band phone and you just use your Wi-Fi connection to connect to the operator network. So normally you have the phone connected to through the internet or through whatever link you want to the operator network based on an IP-based network. What the operator did is just take this IP connectivity and apply it to femtocells. But it needs a bit more information, which we'll flag with later. So UMA, here I put it the femtocell in between, but actually in UMA itself, we never speak about femtocells. There is no femtocells. UMA was designed for the communication between the phone, mobile station, and the home B gateway, which is called GAN controller. That's the GAN C. So all the radio stuff disappears normally, and what you do is use the GAN protocol. Here we have the radio control, here we have the core switching radio, packet switching radio, and then you speak TCP/IP over IPsec, and through GAN controller it has the GAN protocol and converts it to WANAP again and does some signaling. All the mobility management is done on top of it. All the radio management is done in the GAN controller itself, in the GAN protocol itself. And you don't do a lot. You don't say, okay, you're using this channel, this time slot, and so on. You just say, please open a channel. That's all. The femtocell does the rest for itself. This is what's here. So the femtocell speaks GAN and does the mobile radio control by itself. The gateway never will ask. So first, the GAN C is not the one who controls the femtocells, and even the HMS will not say which frequency to use. It's just at the beginning frequency, and on GAN it's very simple. You just say open the connection, and that's it. We have this guy in between. So previously, it connects to the femtocell of a normal 3G, and it's converted to GAN. And these messages are simple 3G, layer 3 messages. What they change on it is because the femtocells needs the keys to talk to the phone. So they extended GAN, which is called UMA in Wireshark because it was developed when it was called UMA. And the home B gateway will send the keys to the femtocells so it can speak in an encrypted way. That's an undocumented extension. Every operator does whatever you want. It's not specified in GAN because GAN is really normally over an IP network. You don't need to send any keys over this IP network. You just open an IPsec connection using the SIM card over the security gateway, and that's it. So the encryption is, they send the encryption keys, and the encryption over the air is only between the phone and the node B. After the home node B, everything is in plain text, and that's quite a difference between, because normally the encryption of the packet goes until the RNC. The node B doesn't have the decrypted packet. It only has some integrity key to know, okay, the frames are okay, I'm going to transmit the frames, and the RNC has the keys to decode the phone traffic. In this case, the keys are forwarded to the home node B. So I have the complete key connection, it's decrypted here, all the phone connection is decrypted here and sent in plain text here. They only rely on the security gateway to have authentication and encryption. Once you're connected to the security gateway, you're in the network, and everything is clear and everything is trusted. Also, it's like always in the telco operator network, it's point to point. So you don't know if the packet is coming from the telephone, you just know it's coming from the femtocell. Let's go back. So yes, the on-node command, Dita found it. Actually, it's just a WANAP command with here's the integrity key, here's the encryption key, here's the integrity key, here are the algorithms. So they copy it from WANAP and they send it. It's undocumented and every operator does how you want, just extending the UMA.
How does traces are got from WANAP?
We didn't have the traces from WANAP. This is the GAN trace. I simply listen to what the femtocell is talking to the home node B gateway. So I routed the device, I got also the IPsec keys, and then I can sniff the complete traffic.
How you go to the IPsec keys?
the femtocell is connected to a security gateway using a proprietary client called ExpressVPN. And once it establishes this connection, it sends the keys to the Linux kernel, which does the encryption and creates the interface and sends everything over this interface. And to send it, it uses to send the keys from the APSec client to the kernel. It uses a standardized sockets, and we just hook with LD preload the send to function to see when it sends the keys. So then we have the keys. Once we have the keys, we can just decrypt the whole traffic. And we will always have the keys somehow. But if you rooted the femtocells, you actually don't need the keys because you're on the device, so you can ask to have the decrypted traffic already. Because it's the standard IPsec implementation in the Linux kernel. So, again, what's important is that the communication between the HOML B gateway and the HOML B is in clear text over GAN. The encryption between the HOML B and the device is actually not mandatory. You go on the web interface, you say, I don't want to use encryption. So you don't need the keys and you don't do encryption. You just need then you will just authenticate, but the over-the-air traffic will not be encrypted.
It's not the security gateway.
No, it's not. So the communication between the HOML B and the phone will be unencrypted, and then the HOML B will use the IPsec terminal created to forward everything in an encrypted way. But everything it forwards is plain text. It's not encrypted.
Such as voice, packet data is still encrypted to the GSM or
no? We haven't looked at all the. We brought to the internet and we see the clear text HTML HTTP traffic.
Huh.
They create, so in 4G they will also have femtocells which are called home evolved node B, and they do exactly the same. All the keys are sent to the home node B again, and the home node B is there to decrypt the traffic and re-encrypt it. So they pushed with stronger requirements, saying you have to have a trusted compartment with some crypto and some stuff. But it's still decrypted, even in the next version of the femtocells, it's still decrypted on the whole node. And then the traffic is in clear text over the IPsec.
The real security clearance is IPsec keys.
Yeah, but once you rooted the device, you have the IPsec keys. And you will always find a way to root the device. How I rooted
The
it.
actual security hold is that they decrypt on the home node.
Yes.
They probably have to.
They don't have to. They just do it. Like in the real 3G network, it's not decrypted in the node B. It's decrypted in the RNC. But I don't know. I have no idea why they did it this way. But they decrypted on the node B. It's not required, but it's done.
But you said that the home node does all the radio resource management.
You don't need the encryption key to do that. You only need the integrity key.
But Kevin, this is all not like this is specified.
Yeah,
It's
exactly.
completely proprietary.
So nothing is specified. It's very vague, and the operator the vendors pushed the femtocell before the specification went out. So you see wild things just everywhere, and if you look at the specification, it's never told that the femtocell is a mix of the node B and the RNC packed in, or it's never told that it needs the keys to do a encryption. It's vague. They have only security recommendations where they say you should have a trusted environment, you should encrypt, and so on. So basically, it's like a Wi-Fi router. It just has a bit more encryption. So when it does, when it installs the latest update, it's encrypted, it's signed, and so on. But else it's very similar. Because all the traffic, like I said, is in clear text, and because all the elements are trusted, and it's just point to point, what we did is just develop a GAN proxy, and some man in the middle who instructs the GAN proxy to do different things, and this way we did all the man-in-the-middle attack you have. So first one, you have interception. Here we have the L3 message in the GAN packets. There's the L3 message, we see it's an SMS, here we have the phone number, here we have the text. So we can intercept. The voice is, how the voice is done is that over GAN, you negotiate an RTP channel. So when it tries to do some voice communication, the GAN controller will say connect to this server and speak RTP with this server. RTP is not encrypted, it's just sent over the IPsec gateway, so you can listen to the RTP. And it's plain IMR, so it's quite easy to decode because we also listen to the voice, we have the tools. The second attack is modification. Because it's not encrypted, it's not signed, it's completely trusted, and it's only point to point. You can just take the L3 message, change the SMS, and send the SMS again. Works perfectly. The last one is injection. That's a bit more difficult because every time you open a channel, you need some authentication. Like in the phone, when you open a channel, you have to authenticate. How we did it is just reads as a man-in-the-middle proxy who wants to open a channel, he asks us for authentication credentials, and we just open another channel to the phone and ask for the authentication tokens. So the phone authenticated, we just forward it back to the network, and now we have the channel that's open. The phone isn't aware of anything, so the user at least isn't aware of anything. Because you paging, you just ask for the encryption in the beginning, for the authentication in the beginning, and then you just reclose the channel. The phone doesn't ring or something like that. It's completely easy. But you need all the time the phone having you need the phone that the phone is connected to the femtocell because the credentials are on the SIM card. And this way we could just open any channel and impersonate the phone's user or make calls, do some HTTP traffic or what. The last one, so Sylvain presented the IMSI detach, and the problem in GSM network is that IMSI detach are specific to, well, IMSI detach are always specific to a VLR. But in real network, the VLR has a limited geographical area. In femtocells, you have one VLR for all the femtocells that's deployed in all the country. So if you have the IMSI of the other phones connected to the femtocell, you can just deconnect all of them at once. And it's really fast to do because you have the IP network. You have the terminal is open, and with the IP network you can send a lot of data, and there's no restriction on the bandwidth. So the bandwidth limitation is just the hardware or the security gateway. The hardware is quite lame, but the security gateway does simple IPsec, IPEV2, EAP SIM, or EAP ACA. This one is EAP SIM. So you just take out the SIM card that's behind, you plug it in the smart card reader, and you can have a laptop connected to their security gateway. You don't need the femtocell anymore. And only the IPsec channel is authenticated. Afterwards, you connect it to it. You're trusted, you can do whatever you want. So you can really have a high bandwidth and do lots of calls. Yeah, exactly. So you don't there's only one VLR for the whole femtocell network. Maybe just because femtocell network is small, and then they will have multiple VLR, but you don't know normally where femtocell is located. You just want to know if it's in France or if it's in this country or not. If it's in this country, you just connect it. You don't care if it's in one area or if it's in the other area. So it's also hard to have VLR for specific geographical locations. That's why you need only one VLR.
But you said in the beginning, it's by design they are only meant to be used by 1, 2, 3, 5 phones.
Per femtocell?
Yeah.
Yes. And that's not about, but what you see for, today it's up to 8, but it's 8 open connections. So you can have as many connected to it.
Normally you have a list of allowed IMSIs that are being accepted.
Yes, normally. You can just
normally, but this is the design.
Yes, exactly. That's why they use only one VLR, because you shouldn't have a lot of customers, but it works. Yes, so we did the demos, I have the demos to intercept, to inject traffic, or to change the traffic, to DOS also, and we also found, so femtocell to femtocell communication is allowed. So for my femtocell, when I'm on their network, I can directly connect to another femtocell. I can go on their web page and just and list the IMSI or see which operator, which customer is in this closed subscriber
You mean
group.
when you have the IPsec tunnel,
Yes,
you
once you
can
have
access all the other machines on this IPsec.
yes.
It's called IP forwarding.
Yeah,
They have already discovered it.
I mean, it's just like you used to be able to do TCP connections through the MMS gateways in former times. It was also not actually designed that way.
So what we did is just connect to a lot of femtocells, not all of them. Go on the web page. We don't need any credentials, and then look on the web page what's written on it. So here we have the IMSI of the femtocell itself. Then we have the IMSI of all the subscribers and his phone number. Because we've seen that on the web page there is this page of neighbors. You just grab this page of neighbors and ask for each cell. You Google where is the cell, and then you correlate, and then you can map all the users which are on the femtocell network. You know their IMSIs, you know their phone number, you know where they live, and because the femtocell is short range, you know it's 25 meters from here. We also find a remote route, so all the attack we presented, like SMS injection or all the man-in-the-middle attack, we can do it also because we have root, we can change the GAN controller. We say don't use this GAN controller, go over my GAN controller. I'll just hold it, but I'm in between, and I can do all the attacks to all of the devices that connect to it. Or you can also say that's not the security gateway, but now you are a femtocell from Kevin Redon AG, and you connect to my security gateway, and this way you just have already a country with a lot of femtocells deployed, and you can create your own operator.
Bot network operator.
Botnet, you can also, what's really nice also is you can use it, so once you have root, you can use it as botnet, because if you find a bug on one of the devices, you have a bug on all of the devices. It's always all the same devices. You're the only malicious one on this stuff. It's always connected, and it has access to a key. So you can do some PDP context switch, which are really heavy load for the HLR, or you can do whatever you want to DOS the network, because you have this femtocell botnet. But yeah, that was the talk, what I presented the talk about here. Just more wanted to present how femtocell architecture and how they are connected. But it's a bad idea to deploy femtocells, to leave femtocells in the hand of the user when you want to have a cheap devices, cheap security, where you will never be able to completely have a perfect protection. And once you have access to the gateway, what we did is. What we found out is what was our aim. So we rooted all the femtocells of their network, or at least we could root all the femtocells of their network. So we controlled all this part because we're also taking the gateway. We can completely control the phone. We can page them, we can use them, we can impersonate them. Well, we can do whatever we want. The security gateway is not a problem anymore because we found out the configuration. So you just take out the SIM card, you put the SIM card in the reader, and I accidentally used the SIM card of the SFR phone and not of the femtocell, and it worked. So you just take any SIM card, I don't know if it still works, but you take any SIM card of SFR and you can connect to the security gateway, and then you have access to these parts. The HMS is also not very secure, so it was like 20 years ago by internet, where you just had computers with default configuration, no firewall on it, so we were root on these devices on the HMS. We didn't root this one because we didn't want to go further on in their core network. And this one is not very stable, so while we implemented the GAN proxy, sometimes I sent the packet in the wrong direction, and this one crashed rapidly. Which we phoned them and say, oh, my femtocell doesn't connect anymore, and years afterwards it was working again. What's also curious is that the femtocell vendor only sells the femtocells. Everything that's in there, the security gateway, the TR069 server, and the HomeD gateway, the operator itself has to take care of it. So the implementation of GAN here is not the same implementation of GAN here. So here we have Ubiquisys giving the GAN implementation. Here we have Kineto. Kineto is one of the biggest UMA GAN software. On the I don't remember what the sub implementation was, but it was also not Ubiquisys. It was a proprietary service. I don't remember this one. The security gateway, it was simple an open source IPsec. So the operator will whatever he wants here. And once you're connected here, because everything is based on trust, once you don't need to have strong configurations. You don't need to protect against evil people because you have mutual agreements. You don't aggress me, I don't aggress you. It's really awful what you're seeing on this network. We have tons of IPs which are just with MySQL, open ports, the configuration of the MySQL database is in clear text, not read protected, and so on. You don't need actually to be root on this device to get configurations. But the important, interesting part for us actually at OsmoDevCon is just that configuring femtocells is done over HMS, that's TU069, there's some implementation, and then GAN, there is no implementation, but it's not hard. All the radio stuff is done on the HMB itself. We don't need to open the channel itself. On GAN, you just say open a channel, it opens the channel, then you push whatever you want on it. And it's S3 messages.
Two stupid questions.
Sure.
So, what's the reason to use the card inside femtocell? Just to establish, to introduce new tunnel.
They use the so here it has the keys on the there's a mechanism called EAP SIM implemented in IPv2 and IPsec. So they just grab some session keys from the SIM card, 3 of them, and with the 3 of them they combine them and then they create the session key for IPsec.
So it's temporary storage for security keys from regular SIM cards.
Yes. You can also, there's also EAP ACA if you want mutual authentication, but you can always fall back to EAP SIM actually.
So the idea was just to tier security aspects from inside the box.
Yes, but the keys for the IPsec gateway are in the SIM card. The box just reads out the keys and connects to it.
So it's just temporary storage.
It's just a key for storage. It's a SIM card. It's a real SIM card from this operator. And they just use the same algorithm you use in GSM. Run GSM algorithm when you have KC keys. This security gateway will send 3 brands, and they will have the 3 KC from direct from this brand are used to create the keys.
Just to process authentication in the same way.
The authentication is done
to authenticate femtocell in the same way as Provis.
Exactly. With SRES and KC. So you have also the SRES, and the SRES is sent back. It's defined in the EAP SIM protocol. It's exactly the same authentication than GSM. It's just stronger because they use 3 tuples and not just 1 tuple.
It's a stupid question. So is it possible to get traces of vacation of keys on the HSS side?
On the HSS, I don't know, I didn't have the keys for it. Actually, so in the femtocell design, the security
it's not about femtocell, just general.
Yes, so the security gateway is connected directly to the AUC. This is how it gets the key from. I don't know how it's connected. I only know the security gateway is directly connected to the AUC.
But in the case of subscriber, it uses
In the case of what?
subscriber, mobile subscriber.
The mobile subscriber uses the SIM card, you mean?
To web mobile equipment communicate HSS.
Oh, the connection. Oh, yeah. The authentication. So the femtocell uses the authentication from the mobile station is still done the same way through the core network over GAN. It's L3 messages, the normal L3 messages you see all over GSM to do user authentication.
I mean, core network side.
On core network, I have no idea what's implemented. Absolutely no clue. But I think they use the same interfaces. Maybe this one is just a proxy for them, translating GAN to RAM, and then it's the same backend. I don't know.
I expect to see a SIP register. I expect to see a SIP register.
You can have a look if you we can give you access. If you have questions. So I was not the only one. I started with Ravi at the beginning, we moved to the femtocell and then Nico joined us. So Nico is more known to the OsmoDevCon'12 community. And then we implemented the GAN proxy and all the other attacks. There's also is the video public?
It's up to you.
We can just stop so I can
Yeah,
tell
stop
you.
this, please.